Section 3.2. The standard form of a quadratic function is f of x equals ax squared plus bx plus c, or y, because y is the same as f of x, equals ax squared plus bx plus c, where a cannot equal 0. If a was 0, we wouldn't have a squared term, and it would no longer be quadratic. That's what quadratic means, is there's a squared term. The graph of a quadratic function is a parabola. We saw that before. That is symmetrical about a vertical line called the axis of symmetry. So here you can see that axis of symmetry in either of these. It's like it cuts it exactly in half. It opens upwards and has a minimum value if a is greater than 0. So here it's upwards, so a must be greater than 0. So this is its minimum value. Its y value is its minimum. It opens downward and has a maximum if a is less than 0. So here it is downwards, and that's its maximum value of y. It has a y-intercept at 0, c, that has a value of c. So it intercepts y right there. So we put x as 0 to get the y-intercept. This one has a y-intercept right there. Use the graph to determine the vertex, the domain and range, the direction of opening, the axis of symmetry, the x-intercepts, the y-intercept, and maximum or minimum value. So a couple things, when you look at these functions, it says the domain is all real numbers. Domain means x, range means y. So what that means is eventually, if we let this graph go on forever, we would hit every single x value. Okay, if it just kept going, it would hit every x value if it kept going. Okay, the range is all of the numbers that are less than this maximum. So y, its range is going to be everything less. In this one, the domain is all the real numbers, and the range is everything greater than the minimum value. So the y values, we can get every single y value bigger than that minimum value. This is really important. For any quadratic function in standard form, the x-coordinate is x is equals to negative b over 2a. So you look at your standard form, and if you use a, b, and c, you can find x. It's negative b over 2a. Couple of other important points. The y-intercepts represent the value of the function when the independent is 0, so when x is 0. The x-intercepts represents the values of the independent variable, so y, when the function is 0. The vertex represents the points which the function reads as its max or min. So anytime a question asks you max or min, you're finding vertex. And the domain or range need to be restricted based on the values of the situation. So we might be talking about people, and it wouldn't make sense to have negative people. Okay, so sometimes we need to restrict it. Or we could be talking about cars, and it doesn't make sense to have a third of a car. That's what they mean there. Okay, so now what we're going to do for each graph, we have to identify the direction of opening, the coordinates of the vertex, the max or minimum, the equation of the axis of symmetry, the x and y intercepts, and the domain and range. Okay, let's do this first one here. So the direction of opening, this is obviously upwards. Okay, now it's vertex. We can get its vertex from the graph right here, so it's negative 2 and negative 4. The other way we could get the vertex we learned about here. The x-coordinate of the vertex is negative b over 2a. So here, my a value is 1, my b value is 4, and my c value is 0, because it's like there's a plus 0. Okay, so remember I said that my x-coordinate on my vertex is going to be negative, I forgot it already, negative b over 2a, negative b over 2a. Negative b over 2a. So let's sub in our value of b. b was 4, so it's negative 4 over 2a was 1. So this is equal to negative 4 over 2, which is in fact negative 2. So if we didn't have the graph, then we could put that x value in and spit out the y. So our function was f of x, or y, is equal to x squared minus 4x plus 4x. So we're going to put in our value of x. So we're going to get negative 2 squared plus 4 times negative 2. So this is equal to 4 minus 8. This is equal to negative 4. And there we got our y-coordinate of our vertex. Okay, so just another way to do that. So there's our vertex. Okay, next thing it asks is a maximum or minimum. So maximum, minimum, we're always looking at our vertex. This is obviously a minimum, and the minimum value, we take our y value. The minimum is -4, because y always gets bigger after that. Any value on our parabola is bigger. The equation of the axis of symmetry, it's always x equals from our vertex, so x equals -2. If we put a line at x equals -2, it would split this parabola exactly in half. X-intercepts and Y-intercepts. So I have two x-intercepts right here and right here. So I can get those from the graph, or what I could do is I could put a 0 in for y and solve. Y-intercept is going to also be right here. The other thing I can do to find a y-intercept is I could take my formula and I could put in 0 for x. So I could go y equals 0 squared plus 4 times 0. Well, I get my y equals 0. So my intercept is 0, 0. Okay, and the domain and the range, I've got a lot of stuff here. Okay, my domain and range, so domain is x. It's all L real numbers. The range is going to be all y's bigger than -4. Okay, we'll try this one together in class, and there's one more example we'll do as well.